Welcome back to VectorX Academy. This is Satyatej, and in today's class we will be learning some problems on combinatorics. So let us get right into it. Let's do this question. Consider all possible permutations of the letters of the word END, ENA, EOL match statements and expression column 1 with column 2. Now, first one, number of permutations containing word ENDEA. ENDEA. Let us take this as whole as group 1. Then the remaining words will be, letters will be ENDEA, NOEL, and all are different. Therefore, the number of ways in which we can arrange G1, comma N, comma O, comma E, comma L will be 5 factorial ways. Therefore, first one will go to P. Now the second one. The number of permutations in which letter E occurs in the first and last positions are E occurs in first and last position. Then let us take 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7, 8, 9. Yes. We keep last and first as E. Remaining words will be T, comma, E, comma, A, comma, N, comma, O, comma, L. Okay? 2, 3, 4, 5, 6, 7 factorial by here n is repeating twice, so 2 factorial. Therefore, the value will be 7 into 6 into 5 factorial by 2. 3. 21 into 5 factorial. Therefore, for option B, it is S. Let us write here. A we got B, B we got S, and now C. Number of permutations in which none of the letters D, L, N occurs in last 5 positions. None of letters N, D, and L. Then let us 2, 3, 4, 5, 6, 7, 8, 9. Therefore, N, E, D, L will occur in these 4 places. And there are 4 letters with letters NDL in letter. Therefore, number of ways will be here. For filling these 4 will be 4 factorial by 2 factorial into number of ways in filling this one will be the letters will be E, 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 A, O, L. So, we will remove it. This will be 5 factorial by 3 factorial. Therefore, the value will be 4 into 3 into 2 by 2 into 3 into 2 into 5 factorial. Number of possible ways. This is possible will be 2 into 5 factorial. Therefore, the answer will be Q. Dth one, number of permutations in which letters A, E, O occur in odd positions. D, 1, 2, 3, 4, 5, 6, 7, 8, 9. First position, second position, third, fourth, fifth, sixth, seventh, eighth, and ninth. 1, 2, 5. There are 5 odd positions and there are 4 even positions. Then, and how many letters are there in with letters A, E, and O? 5 letters. E, comma, E, comma, E, A, O. And remaining are N and DL. Comma, N, comma, D, comma, L. Now we have to arrange these 5 in odd positions. Therefore, the value will be 5 factorial by 3 factorial into, and we have to arrange this in the remaining positions, that will be 4 factorial by 2 factorial. Therefore, again the answer will be, number of ways in which this is possible will be 5 factorial into 2. Therefore, for option, for D question, answer will be again Q. That is A goes to P, B goes to S, C goes to Q, and D goes to Q. Now let us move into next question. Now let us do this question. Let A denotes the number of all n-digit positive integers formed by digits 0, 1 or both, such that no consecutive digits in them are zeros. And let Bn equals to number of such n-digit integers ending with digit 1 and Cn be number of such integers ending with digit 0. Then which of the following are correct? Now they have given that An equals to number of n-digit positive integers with 0, 1 and no two zeros are then can make like let An will be total number of ways in which no two zeros are together, and Bn will be total number of ways in which no two zeros are together, and the last one is 1. Last digit will be 1. And for Cn, same, but last digit will be 0. Therefore, we can write An as Bn plus Cn. Since for An, no two zeros are together and last one should be 1 or 0. So for 1 it will be Bn, for 0 it will be Cn. So An equals to Bn plus Cn. Now take this as equation number 1. Now for second equation we can take it as like this. Now Bn equals to total number of zeros, total number of ways in which no two zeros are together and the last one ends with 1. Then and no, let us take C1. Now we can think of Cn as all numbers, no two zeros are together and last one should be 0. If last one should be 0, then the previous last one must be 1. Therefore, we can take this as bn minus 1, where all, no two zeros are together and last digit is 1. Therefore, cn equals to bn minus 1. Let's take this as equation number 2. And for third equation, uh, similarly, if we take bn, then all digits are, no two zeros are together with last digit as 1. Therefore, we can take this whole n minus 1 digits as an minus 1, since large digit can be 0 or 1 and no two zeros are together. Therefore, we can write bn as an minus 1. This will be third equation. From these three equations, we can write that an equals to an minus 1 plus bn minus 1. Since a equals to bn, an minus 1 equals to bn, and bn minus 1 equals to cn. And we know that an equals to bn plus cn from equation number 1. Therefore, again we can write an minus 1 plus an minus 2, where we can write an minus 2 as bn minus 1, which is cn. That means an equals to an minus 1 plus an minus 2. Now we will check the options. See, the first one is right. A17 equals to A16 plus A15. I have given that C17 equals to not equals to C16 plus C15. Let us see that one also. Now here, what can be Cn written as? Let us take like this. An can be written as Cn plus 2. From here, as Bn equals to Bn minus 1. From equation number 2. And Bn minus 1 equals to An minus 2. From equation number 3. These two from equation number 3 and these two from equation number 2. Therefore, we can write An as Cn plus 2 and An as Bn plus 1. Therefore, from this equation, let us take this as 4. We can write it as Cn plus 2 equals to Cn plus 1 plus Cn, and Bn plus 1 equals to Bn plus Bn minus 1. Therefore, option B and option C are wrong. For the last one, A17 equals to C17 plus B16. A17 equals to C17 plus B16. This is wrong since A17 equals to C17 plus B17 and B17 not equals to B16. Therefore, option A is the right answer. Now let us go into another question. If R, S, T prime are prime numbers and P and Q are the positive integers such that LCM of P, Q and R are LCM of PQ is R square plus S power 4 plus T square, comma T square. Then the number of order pairs of P and Q are. Let us take P as P equals to R power X, S power Y, T power Z, and Q equals to X, R power X1, X1 and X2, s power y1 and y2 and t power z2. Then LCM of p comma q equals to r square into s power 4 into t square. Then x1 comma x2 max will be 2. Maximum of y1 comma y2 equals to 4 and maximum of z1 comma z2 equals to 2. Then first we can choose one should be at least 2. So from x1 and x2, let us take number of ways in which we can choose x1 equals to 2 or x2 equals to 2 will be 2 ways into y1 means maximum of y1 and y2 will be 1. Y1 will be 2 ways and again for z1 it is 2 ways. Then if one of them is let us say x1 equals to 2, y2 equals to 4 and z2 equals to 2, then x2 can be 0 comma 1 comma 2, 3 ways. Y2 y1 will be 0 comma 1 comma 2 comma 3 comma 4. Let us remove the equal ones. First we will see only these ones. This will be 2 times, this will 1 2 3 4 and for z1 again 2. Therefore the answer is number of ways in which one of them both are not equal, x1 and x2, y1 and y2, z1 and z2 will be 1 2 3 32 32 into 4 61 28 ways. Then again after that both are same means x1 comma x2, x1 equals to x2 equals to 2, y1 equals to y2 equals to 2 and z1 equals to z2 equals to 2. This will be again 3 times. That one for case another case x1 comma x2 equals to for this y1 again y1 comma y2 max equals to 4 max of z1 comma z2 equals to 2. Therefore the values number of ways will be here 2 into 4 into 2, 2 into 2 into 4 into 2, 32 to 2. For only x1 equals to x2 equals to 2, there will be 32 ways. Equals to y2 equals to 4, there will be 2 into 2 into 2 into 2. Since max of x1 comma x2 equals to 2 and max of z1 comma z2 equals to 2, number of ways will be 1 2 3 4 16 ways. 16 and for z1 equals to z2 equals to 2 again 32 ways. Therefore number of ways now until now we got 128 plus 32 plus 16 plus 32. Now another case x1 equals to x2 equals to 2 comma y1 equals to y2 equals to 2 4. This will be 2 into 2 4 ways and for uh, we are taking x1 and y1 pair. For y1 y pair and z pair, we will get again four values, and for z comma y x pair we will get again 2 into 4 8 values. That means 8 plus 4 plus 4 16 plus 16 plus 1, where this one comes from all three. X1 equals to x2 equals to 2, y1 equals to y2 equals to 4, and z1 equals to z2 equals to 2. This will be one pair. Therefore, number of uh, ordered pairs of P and Q will be 128 plus 32 plus 16 plus 32 plus, that's it, plus 16. That will be 128 plus 64 plus 32 plus 1. That is 0 5 5. Therefore, the number of ways will be 225. Pairs are 225. Now we will go into another question. Words of length 10 formed using letters A, B, C, D, F, I, G, H, I, J, and X be the number of words in which no letters are repeated, and Y be number of words such that exactly one letter is repeated twice and no other letter is repeated. Then Y by 9x is. Now for this, let us first find out value of X. That will be 10 factorial base, since it is no word is repeating, and we have to form a letter of word with letter 10 letters. Y will be y equals to, first we have to choose one number 10c1, which will be repeated, and we have to choose other 8 numbers from 9 numbers, 9 letters, that is 9c8, as they are non-repeated digits, non-repeated letters, and then we have to arrange them. That will be done by 10 factorial by 2 factorial ways. That will be 10 into 9 into 10 factorial by 2, 5 times. That implies y equals to 5 into 9 into 10 factorial. That implies y equals to 45 into 10 factorial. Therefore, y by 9x will be 45 into 10 factorial by 9 into 10 factorial. That means y by 9x equals to 5. Hence, the solution for this question will be 5. Now let us move into next question. That is, let n be a number of ways in which 5 boys and 5 girls can stand in a queue such a way that all girls stand consecutively in a queue. And let m be a number of ways in which 5 boys and 5 girls can stand in a queue such a way that exactly 4 girls stand consecutively in a queue. Then the value of m by n is. Now for this, let us first find the value of m. M equals to, no, first we will find out the value of n. N equals to, for this, let us make a new term called g, where g is all the number of ways, means we are grouping all the girls in a one group, like g1, g2, g3, g4 and g5. Let we make this whole group as a one singular letter. Then we will arrange G, B1, B2, B3, B4 and B5. These are all five boys, and in the G there are five girls. Then we should arrange these five. That will be n equals to first. Inside the arrangement of G, we can arrange G means number of distinct values of G will be. That means G will be number of G's will be 5 factorial into, and now arrangement of G, B1, B2 and so on up to B5 will be 5 plus 1, 6 elements. We should arrange them. That will be 6 factorial. Now we got n. Now we will find out m. For m, they have said that exactly 4 consecutive girls are should be in a queue. So let us take G as group of 4 people. G1, G2, G3. Then then will be small g as the fifth girl, capital G, and all the boys B1, B2 up to B5. 7 elements, and we should arrange such that these two are not together, small g and capital G. That can be done in we can make that like by exclusion principle. Total number of ways 7 factorial minus number of ways in which we should make this as a group, then will be like 6, 2 factorial into 6 factorial. These two groups can be arranged in 2 factorial ways, and the whole will be arranged in 6 factorial ways. That will be 7 factorial minus 2 into 6 factorial, that is 6 factorial into 5. Therefore, m will be first arrangement of all girls 4 factorial ways into choosing one uh, exclusion girl means the small g, that will be 5c1 into the total number of ways 6 factorial into 5, that will be 5 into 5 factorial into 6 factorial. Therefore n by m will be m by n will be 5 into 5 factorial into 6 factorial by 5 factorial into 6 factorial. That will be 5. So the answer will be 5. This completes our today's lecture, and we will meet you in next lecture.